Netflix relies on Gen AI to power its recommendation engine, processing millions of user requests daily. Imagine if Netflix couldn't reliably extract structured data like movie titles, genres, and timestamps from user requests. It would be a chaotic mess. Here's what 95% of developers overlook. LangChain output parsers transform LLM responses into clean, usable data structures. By the end of this video, you'll know how to use them to build robust, production-ready AI applications that extract structured information without the headache. We'll cover everything from Pydantic models to handling complex XML outputs. Remember this, we'll see how this structured data extraction impacts Netflix's user experience later. This is where most people go wrong. They underestimate the importance of structured data. Let's dive into the core concepts of structured data extraction. At the heart of it all is the output parser interface. Think of this as the blueprint for all your parsing needs, like a data contract ensuring data integrity. In practice, it's like a function signature that guarantees a specific output type. It defines two critical methods: parse, which takes the LLM's text output and transforms it into a Python object, and get format instructions, which returns a string that you include in your prompt to guide the LLM's output. This sets us up for structured data extraction, where we want to reliably pull specific information from the LLM's response. The key is providing clear output format instructions to the LLM. These instructions tell the LLM exactly how you want the data formatted: JSON, XML, a list, etc. Without these instructions, you're at the mercy of the LLM's unpredictable formatting. We use output format instructions because they constrain the LLM's output space, making parsing more reliable. LangChain provides several built-in output parsers, including list output parser, date-time output parser, and comma-separated output parser, each tailored for specific data types. With the foundation in place, let's tackle how this works under the hood, focusing on the Pydantic output parser. This is your workhorse for enforcing structured output. It leverages Pydantic models to define the schema for your data. First, you define a Pydantic model with the fields you want to extract. Then, you initialize the Pydantic output parser with this model. This brings us to prompt construction. The prompt must clearly instruct the LLM on the desired output format. This is where get format instructions shines. It generates a string that you can directly insert into your prompt, telling the LLM exactly how to format its response to match your Pydantic model. Finally, we integrate this into an LLM chain. You create a chain that takes user input, feeds it to the LLM with a formatted prompt, and then passes the LLM's output to the Pydantic output parser for parsing. The data flow is simple: user input, prompt plus LLM. Output, Pydantic output parser. Structured data. We use Pydantic because it provides strong data validation and serialization, ensuring that the output conforms to the defined schema. An experienced interviewer will probe, what happens if the LLM returns data that doesn't match the Pydantic model? The answer is that Pydantic will raise a validation error, which you can catch and handle gracefully. The reason we use LLM chains is that they provide a structured way to orchestrate multiple LLM calls and data transformations, making complex tasks easier to manage. Your interviewer will push back here. Why not just use regular expressions instead of Pydantic? The answer is that regular expressions are brittle and difficult to maintain, especially when dealing with complex or nested data structures. Pydantic provides a more robust and type-safe solution. We use LLM chains because they simplify complex workflows. Think of it like an assembly line for LLM tasks. Here's where it gets interesting. Let's walk through a hands-on example. First, we set up our environment with LangChain and OpenAI. Now let's see a common pattern. Extracting JSON output, we define a Pydantic model for a product with name, description, and price fields. Then we initialize the Pydantic output parser with this model and construct our prompt, including the format instructions from get format instructions. We pass this to the LLM, and the parser magically transforms the raw text into a Python object. Now here's the twist. What if we want XML output instead? LangChain provides an XML output parser. The process is similar. Define the XML structure, initialize the parser, and include the format instructions in your prompt. Remember the 95% of developers we mentioned in the hook? This is where it matters. They try to parse these complex formats manually with regex. Output parsers save you hours of frustration. Stop. Think about this. Without structured output, Netflix couldn't reliably process user requests for specific movies or genres, leading to a frustrating user experience. We use XML output parser when integrating with legacy systems that require XML data formats. Companies like Airbnb use XML output parser to interact with older booking systems that rely on XML data exchange. Few people know that XML is still prevalent in many enterprise applications. The reason we use JSON output is because it's lightweight and easy to parse. JSON is better for modern web applications, while XML is better for legacy systems. Building on that demo, let's discuss best practices for using output parsers. The biggest mistake developers make is not anticipating parsing errors. LLMs don't always return perfect outputs, so robust error handling is crucial. Always wrap your parsing logic in a try-except block to catch potential exceptions. When an error occurs, provide feedback to the LLM to improve its output format. For example, if the LLM returns invalid JSON, tell it to strictly adhere to JSON syntax. For production tips, consider implementing retry mechanisms with exponential backoff. If parsing fails, retry the request with a slightly modified prompt. To improve performance, cache the LLM's output to avoid redundant parsing. The trick is to balance reliability with performance. A tech lead will push back, why not just use the OpenAI API directly? Defense. This gives you provider-agnostic abstractions. Switch from GPT-4 to Claude with one-line change plus built-in retry logic and streaming. Always validate the output against your schema because LLMs can sometimes hallucinate data. The common mistake is assuming the LLM output is always correct. Always provide clear and concise format instructions to the LLM because vague instructions can lead to unpredictable output. Always test your output parsers with a variety of inputs because LLMs can be sensitive to subtle variations in the input data. We use try-except blocks because they prevent your application from crashing when parsing errors occur. The common mistake is not logging these errors for debugging. Having locked down best practices, when should you use output parsers? Use them whenever you need structured data from an LLM. If you're just generating free-form text, they might be overkill. Now, what are the alternatives? You could manually parse the LLM's output with regular expressions, but that's fragile and error-prone. Another alternative is to use a dedicated data extraction tool, but that adds complexity to your pipeline. The key insight: output parsers provide a simple, reliable way to extract structured data from LLMs. Remember the 95% of developers we talked about? Don't be one of them. Start using output parsers today to build robust, production-ready AI applications. Consider using datetime output parser when extracting date and time information from user queries. List output parser is useful when you need to extract a list of items from the LLM's response. Click the link in the description to get started with a free LangChain tutorial. Remember the millions of Netflix users we mentioned? This is where structured data extraction matters most, ensuring a seamless and personalized experience. We use output parsers because they simplify the process of extracting structured data from LLMs. They are better than regex because they are more robust and easier to maintain. They are better than dedicated data extraction tools because they are simpler to integrate. A key trade-off is that output parsers add a layer of abstraction, which can sometimes make debugging more difficult. However, the benefits of structured output and error handling outweigh this cost.